iMout is a prototype application developed by Design and Construction Strategies for Autodesk Government. It provides its users with a realistic 3D urban environment with components comprising the inside, outside, and under infrastructure of a selected urban context, which in the pilot application was Baghdad, Iraq. The area was developed using satellite data. The context buildings were extruded into 3 dimensions using photogrammetry, and to them, images were applied as facades, giving the model photographic realism. The application includes tools, one of which is a viewshed analysis, which indicates graphically, in red and green, what can and cannot be seen from any user position within the model environment. The model data is dimensionally accurate and can reference the correct geospatial coordinates for any location in the model. Utilities, the power grid, and sewers and entourage elements were also modeled and added to the scene. The combined model was integrated into a gaming engine, which provides the users the capacity of flying over the 3D urban environment, as well as zooming in and interactively navigating inside the detailed multi-story building model. A target building was developed in greater detail using building information modeling software and was then integrated within the context model. The target building is a fully developed model with 3D components that include its architectural envelope, structural frame, ducting, piping, lighting fixtures, furniture, and finishes. These components can be toggled on and off in the application so that the viewer can see and analyze elements piecemeal or whole. The gaming engine allows users to navigate through the environment much as they would a real building. The model can be viewed in single or multiplayer modes with up to 16 participants interacting via the web, each represented by their own avatar. The application can visually display building information in multiple ways. This window shows the building separated out by 3D floors. Users can change the display via their mouse controls. The simulation model can contain representations of all key assets inside the facility or in the surrounding urban context and associate those components with external database records. Sustainabuilding was created by DC Strategies as a prototype educational tool for individuals who would like to learn more about the criteria used by the U.S. Green Building Council's LEED rating program. With Sustainabuilding, users navigate through a 3D virtual building using game engine technology and evaluate various options for acquiring LEED credits. A simplified scorecard based on LEED is also part of the user interface and serves multiple purposes. As the user moves through the model and selects sustainable building components, the application records credit points by coloring in a scorecard square. Users can also use the scorecard as a menu to bring up outside information on each credit. By clicking on a square, PDF documents, photos, website links, and other useful information will be displayed in order to give more background on each LEED credit. The user interface also includes a key map to pinpoint the user's location as they move around the site or on each of the floors inside the building. The user can navigate through the 3D model by use of the keyboard's arrow keys and also jump to various preset locations in the model. Hovering the mouse pointer over sustainable components will display text describing the LEED credit that the building object is involved with. Additional information about the highlighted LEED requirement is displayed in the information box in the lower left of the user interface. Sustainable components are interspersed throughout the entire 3D model, and multiple objects can illustrate a particular LEED credit. The application also visually illustrates several focus topics, such as what is involved in sustainable site credits, visually explaining how site density is calculated, or illustrating site redevelopment credits, such as brownfields, or show a 3D phasing diagram illustrating new and existing construction. The model can be viewed in multiple ways. A pop-up window displays 3D plans for each floor and can be dynamically rotated and zoomed by the user mouse. The application also offers the user the capability to display a 3D sectional view that cuts through the entire building model and can be dynamically rotated by the user and zoomed in and out to see the model in more detail. All components in the model have been rendered with realistic colors, textures, and lighting to display a lifelike rendering of a building project. The model was developed so that the visibility of different component groups can be toggled on and off. This capability works in any view in the application and allows the user to see different parts of the model better, such as seeing the project's HVAC ducting runs by making ceilings, floors, or partition walls transparent. The model also includes database information for components in the surrounding context. In fact, any object in the application can have a database record associated with it. Sustainabuilding includes additional dynamic visualizations to illustrate sustainable design areas of interest, such as showing solar penetration areas adjacent to the curtain wall at various times of the year, or how building siting is influenced by the floodplains of a nearby river. Since the application is fully three-dimensional, concepts can be illustrated easier to a range of users, many of whom have little to no training in reading drawings or how criteria affects building design. Sustainabuilding includes a help facility which describes the application's features in text and with graphics. It also includes a short visual tutorial to describe the application's workflow to new users and explain features of the tool. In conclusion, Sustainabuilding can be used by students, building owners, or anyone else involved with or interested in green building projects to help increase understanding of the complex and detailed discipline that is sustainable design.